school now.
What did she accidentally miss something?
She was here today.
Who wasn't here?
I don't know. I think everybody.
Hi, Lucas.
Lucas is in Algebra 2. He doesn't watch pre-cal notes. But these girls, Michaela and Chase, which are not both girls, are giving blood, so they might need to watch the video.
Chase, if you're watching this, you're
Chase won't watch it. We know that's true. Multiplicity has to do with when a zero repeats itself. Before precalculus, we kind of call these repeated zeros. And if you have a zero that is repeated, then we say it has a multiplicity for whatever power's out there. There's a lot of letters in this, but the big idea is if you have something to the k power where k is bigger than 1, then you're going to get a repeated zero for whatever that zero is, and we're going to say it has a multiplicity of k. And not only is that going to determine whether it crosses or touches the x-axis there, we're going to look at what multiplicity does at the x-axis. The bigger the multiplicity, what happens on the graph. And so I'm going to graph these on the graphing calculator in a minute when you've all written this down. You don't have to graph them on your paper, but if you want to kind of show what happens, I'm okay with that. They were reviewing or something yesterday. What do you do in Miss Gardell's class when you guys used to play like a fly swatter game where you like run into the chalkboard? Now that sounds like someone's dying over there. Or when they watch Selena, I always hear every word of it. We talked yesterday about the power. If this is an odd power, it will always cross the x-axis at the 0. If it's an even power, it will just touch the x-axis, whether it comes up and touches underneath it and back down, or it comes down and touches it if it's an even power. And so this is going to help us when we graph these by hand today to know these things. And so what I want us to do, what I'm going to do, is on the graphing calculator here, I'm going to graph both of these. They both have a 0 at 1, but I want to show you the difference of a power of 2 and a power of 4. They're both parabolas, but I want to show you how they look different. Brandon, keep it together. You are? Oh. Yeah? Do they have treadmills and TVs yet? Good. Brandon, what are you guys talking about?
there's nobody behind.
Hey, here's one of my articles of clothing from brands. South scrap, not kidding, it doesn't count. Could have easily ordered that.
Here's 2013, it says.
Could have easily ordered that
Hey, I
online.
bet you it's not Dave's face.
Well, everyone else yeah, Luke was on the track team. Look at his shirt. Yeah. He's got some shirt. Oh, Chase. We're recording notes for you, dude. Hey, Chase. Hi, Chase.
Chase,
Chase, give me a sec.
All right, so I'm going to graph x minus 1 squared and x minus 1 to the 4th, and I zoomed in. I want you to look at the x-axis when it graphs these. So it's going to do x minus 1 squared first, comes down, makes a nice little parabola, right? And now look at x minus 1 to the 4th. Oh.
It's fat.
What does that look like? What's happening at the x-axis with the higher multiplicity?
Maybe not.
What if I do x minus 1 to the 6th? What do you think is going to happen?
Whoa.
Not even a function.
It is a function.
It's a line?
I don't know why it's a line, but Oh, and it comes out even more.
Oh,
So,
What about x minus 1 to the 10?
so what I want you to get from this is multiplicity. One, it's an even multiplicity, so that's why it's just touching and not crossing. But it kind of looks like it touches a lot more than at 1, but it doesn't. It just flattens out there. So the higher the multiplicity, the more it flattens out on your x-axis. What's going to happen with odd multiplicity?
It goes outside of it.
So what if I do same thing, but let's do x minus 1 to the third? Oh man, what's happening?
Holy fuck.
It's okay. Like
Case probably that. Jay, that's a brain.
x minus 1 to the third. And then let's do x minus 1 to the fifth.
Oh boy.
So remember that cubic graphs make that little, I don't know, I call it an S shape, it's really not an S. Grady calls it a backwards roller coaster, but like that little curve thing, right? I know, I don't know. But watch what happens. That's x minus 1 to the third. And then here comes x minus 1 to the fifth. You agree again, the higher the exponent, the more it flattened out. But the difference is when it's an odd exponent, it's going to cross the x-axis. It's not just going to come and touch and come back down. But notice how flat it is. So when I see you graph a cube or a fifth power, I want to see that little flattened out thing. And the fifth power is really flattened out. And we're going to graph some of these by hand today, and I just want to give you that idea of what multiplicity is when we do that. So on the notes here, you don't really have to write anything down for this. It's more just an exercise together that we can think about, that the higher the multiplicity, the more that it flattens out on your stuff. So I don't really know why number one, but let's just jump right in here to this one. But you can label number 1 if you want.
Of course, it has to be negative.
Come here, blood type, Chase.
A negative.
Ooh, I'm A positive. A little better.
I'm O negative.
I'm A plus. My sister's A negative and I'm A positive, and I always told her I was better. I was A plus.
I'll get an A plus.
What's the best one? O negative?
I'm O
It's
negative.
universal.
You're not owning it. Yes,
I am.
All right, so notice the directions on this. It says state the degree and list the zeros, state the multiplicity of each zero, and if it crosses or just touches, and then sketch the graph by hand. You have 2 problems on your homework tonight with these same directions. You have a question or 2 on your test for this chapter with the same directions, except for I might also throw in there describe the behavior, which means it's probably not a 10-point question on a test.
Oh my gosh.
Write the equation. These are kind of my steps of how to graph these. You don't necessarily have to write those down. But using all the things we have, we should be able to graph this without picking a million points. Chase, do you have to go run miles after school even though you donated blood? You get exempt from it, don't you?
I can just sit there. Maybe I ain't blue too. Okay, well, if he actually has blue athletic team. Same as this stuff. It's just the free graph.
He's gonna pretend he gave blood so he doesn't have to practice tonight.
No, Dirk will do the listening, of course.
Brandon,
What?
settle down. Yeah. So I can give this to Mr. Aker, this recording, and say, listen to Joe. Joe says he's gonna fake it.
I like to listen to that. Did you have something to drink? Chips? Like alcohol? No. It says have something to drink. It says fluid intake. Yeah, I had some. Do you have something to eat? Yeah, I had a piece of Sprite.
A cigarette.
Did you say that area was 10 cents? Pass out.
Is anybody passed out today?
Oh, rascals.
I think Jake Shore threw up a bunch.
Yeah, he was gone a very long time. So
No, it's not. No, you have to leave that bandage on for at least 4 to 6 hours. It's still on.
Lucas, give that back.
No, I get it.
It's a gift.
Put it away, or I'm gonna take it. It'll be my gift.
No, that's stealing.
Excessive stealing.
What are the answers to that?
Rough stuff. We're here. Darn.
Yeah, I missed one coming over.
We only went over.
Girls took donuts to that track out.
Number 6. They did do it.
Really?
Yeah. Going around. She's going hardcore. Donuts. She's going around this whole.
Oh. What's the degree of this?
3.
No.
4. Negative 1.
The leading coefficient. You have to multiply, right? Multiply the highest x's together from each term. So we could say the leading term on this would be negative x to the 4th. So if it's an even degree, degree 4, it asks for the degree. So write it down. If it's an even degree and a negative leading coefficient, which way are my arrows going to point?
Same way.
This way? This way, because it's negative. It does not ask to write it out. If it says describe the end behavior, you have to actually write out all the infinity stuff. It doesn't ask, but I'm just going to write next to this to remind myself that both arrows on my graph should point down. It says list the zeros. Can I list the zeros here pretty easily?
Yeah.
Just like on the homework that you didn't do yesterday, Brandon. You just have to set each one equal to 0. So if we set this equal to 0, we're just going to get x equals 0. If we set this equal to 0, we're going to get x equals 2.
That's weird.
Here's the new part. Yesterday you just listed the zeros. Today you have to say the multiplicity. The multiplicity is just the power on each 0. So this is the third power. So we're going to say it has a multiplicity of 3. State the multiplicity. You missed that part, which is this big long thing that I can show you after we're done with the notes. But we wrote out multiplicity. But basically, the short answer is the multiplicity is if the power is bigger than 1, it's just whatever the power is. It means how many times the 0 repeats itself. Okay? It's okay. They can still hear me. No one watches this. They're back. I might have said, Chase, I'm just going to tell you now, that they said who was absent today in second hour, and I said no one, and they said who's absent now, and I said no one. Well, these girls that are gone, I mean, Chase is gone, he's not a girl. I'm just saying it now. I didn't mean to say girls, but I said
The
girls.
whole class laughed at you.
And I'm apologizing in advance. I didn't mean it. And
I'm not going to look up.
I know you weren't, but they're telling us.
You're stepping on the board. You're going to mess up the board.
The other thing that we learned both yesterday and today is if this is an odd power, that means it's going to cross. And even more importantly, it's going to cross with that little S part there, right? Here's a part that we always discuss because some people disagree. But if you look back at our definition of multiplicity, it only has multiplicity if the power is bigger than 1. So if there is no power on here bigger than 1, then it has no multiplicity. It means it just crosses the x-axis without flattening out. So this, we would say no multiplicity. If you just didn't write anything there, I would know that you mean no multiplicity. Okay? But it is just going to cross. Because 1 is an odd number. Okay? Yeah, each 0 has its own, can have its own multiplicity. So let's graph what we know, and I want to show you why it's nice to know this stuff. So if you haven't drawn a little graph yet, draw a little graph. Show my dear, I feel like you need to pay less.
Do they pay sometimes to get blood?
You what?
So you could go and sell your plasma for 18. In what? Sell your blood plasma.
How much is that?
Like 50 bucks a pop.
It's like all your white blood
What's a
cells.
pop of
So
blood?
you're sick all the time because you're giving away your ability to fight.
Oh, okay.
Like every still. Yeah, I think it's pretty. I think it's like 2 weeks.
Yeah.
And so people do it every 2 weeks as like a source of income.
$100 a month.
And then they're sick all
If
the
you're
time.
in need of money, go.
College kids do it a lot.
Chase is down at 65.
I turned 18 is the first thing I want to do.
He just has to be sure.
So, what do I know? I know
You have to be popular guns to love.
it has a 0 at 0, and I know it has a 0 at 2. I could just pick points from here, but I also know the end behavior. I know both arrows have to point down. And if these are the only two zeros, do you agree that this has to go down and this has to go down? Which means, do I really have to pick a whole lot of points to make a very accurate graph here? I think if we just pick here to figure out where this goes, we're going to have a pretty good graph. So the idea is if we use all the stuff we know, we don't have to make this giant XY chart just picking random numbers. So if I pick 1, you can type it in your calculator. Be careful though. I think we're going to get -1 times -1, which is 1. I do want you to be careful about this multiplicity though, because I am going to check that you make a difference between a multiplicity of 3 and no multiplicity, which means I'm going to go back and erase this a little bit. Because at 0, if it has a multiplicity of 3, I know that it should kind of bend at the x-axis. So I'm going to try to make that bend, sort of like that. Because it has a multiplicity of 3, like it's not just a perfect little parabola. But then it's going to turn and come back down on this side. I need to make a thinner line. It's exciting.
I'm never ever going to use this power.
Well, you're going to use it to pass this class, so after that, I don't really care if you ever use it again.
So how do you find the multiplicity?
It's the exponent, it's the power. It's whatever the power is, that's the multiplicity.
Oh.
Like, I just feel like I went over too far here. I want to see that you made some effort to make that shape. I'm going to be lenient on that, but what I want to see is it looks different than this that has no multiplicity than a one that has a multiplicity of 3. Does that make sense? Let's do another one. Because there's no power out there, right? Like there's no power out here but a power of 1. So if it doesn't have a power, it's just going to go straight through the x-axis. Does that make sense? And so you look at each individual 0. I think it will help when you do this. So let's talk about the degree and which way the arrows are going to go first, and then we'll talk about the zeros and the multiplicity again. The degree is going to be the highest exponent if you multiply this all out. So if I multiply this out, do you agree the leading term is going to be x to the 3rd? A bunch of other stuff. And if I multiply this out, that's going to be x squared. Which means if I put those together, that's going to be x to the 5th, which means degree 5, and you've got to know when it's an odd degree, the arrows go in opposite directions. It's positive leading coefficient. The positive side is going to go up, the negative side is going to go down. If it doesn't ask you to do in behavior, you could just pick points to know that, but if you know it already, it really saves you from picking a lot of points on your XY chart.
How do we know the right side?
It's the chart we wrote out yesterday. You just have to know it. Remember that we wrote out yesterday? You need to study it. Learn it. Live it. Love it. Zeros. If I solve this, that's going to be a 0 at 1. If I solve this, that's going to be a 0 at -2. That's what you were supposed to do on your homework last night.
Oh, we all did that.
Don't lie, Joe. I saw your paper.
Okay. Okay, I feel like if Chase doesn't have to take that.
That means you don't have to think you do.
Chase does his homework. for the homework quiz, right?
Oh, yeah.
We already had one this chapter.
We usually have 2.
Which means we'll be taking one tomorrow. Yeah, we'll have
Or after.
Multiplicity. Multiplicity is the power that's up here. So since there's a 3 there, I know there's a multiplicity of 3. What does that tell me? It tells me that when it crosses, it's going to flatten out like x cubed. And because it's odd, I know it's going to cross there. At -2, it has a power of 2 on it, which means it has a multiplicity of 2.
Touch.
And because it's even, that means it's only going to touch the x-axis there. It's not going to cross the x-axis. So again, using this information, we should be able to get a good idea of what our graph should look like, maybe having to pick 1 or 2 other points. So if I graph a 0 at 1, and I graph a 0 at -2, and I might go back and erase this in a minute, but I can at least get an idea that I know the end behavior because it's odd and the leading coefficient is positive. I know this side's going to go down, and I know this side's going to go up. And I can even go as far to say that at -2, it just touches. So which way should this graph go after it comes up and touches at -2? Back down, and then it should come back up to cross there. I don't know where, that's where I have to pick some points, but I at least know what should happen. If I get a positive number up here, then I know I've done something wrong, because a multiplicity of 2 is never going to cross the x-axis there. All right, so that's why we use this to help us make accurate graphs. But I'm going to pick a couple points here, and I'm going to just pick 0 and -1 to see what happens, and then I'll go back and graph with my multiplicity. But if I plug 0 in there, you can use your calculator, you can type this in all at once, use your parentheses. But if you plug 0 in there, you're going to get -1 times 4. No, yeah, which is -4. If you plug -1 in there, here's why you should pick the points in between, because you might just like make this go down. But I think if we plug -1 in here, it really goes down a lot further. Because if you plug -1 in there, you're going to get -2 to the third, which is -8 times 1 is -8. So here's where I think pencil is the best choice here, because I always tend to do a lot of erasing when I'm making these graphs, because I want to make sure that it looks right. At x squared, it should come up and touch, which means I'm going to go ahead and erase this, even though it was okay. But I know it's just going to touch here, so I'm just going to kind of wing it like this and come down. Oh my goodness, like this. And then here's the thing. At 1, it has a multiplicity of 3, which means I know it has to kind of flatten out and make like that x cubed. So I'm just going to kind of wing it like that, right? Might be struggling a bit there, but I think it should look more like that than what I've drawn, but you know, you get the idea. All right, I'm going to fix it again. Oh, that's a little better. If you ignore that other part there. See why having a pencil is nice, or a magic eraser. Sometimes on tests, people like to draw an arrow here and say, this is bent, and it makes me laugh, because I should be able to see it. You shouldn't have to write me a note, but that's what I'm looking for. So looking at this, I can say, I know that has an even multiplicity. I know that has an odd multiplicity. I can tell the degree by looking at it also. Huh? What? If it has an odd multiplicity. So anytime it has a multiplicity of 3 or 5, I don't think we ever graph anything higher than that, you make it kind of upside down roller coaster, as Grady says. Backwards roller coaster. I like the homework directions on this because it says using only algebra. I don't know what else you would use. Magic.
They said, don't even take one shot. Just like, and have like a hangover from basic, like really cheap.
like, yeah, do this for a living. Wait, how long do you have to wait in a given one?
I don't know. I think it's like 30 or 60 days or something. Which you want your body to have time to replenish.
See, but that's what I don't think video. It just gives you answers that have enough what has something problem, but nothing to do with the answer.
Right, because I kind of changed directions a little bit. You didn't have to grab on those ones yesterday.
I wasn't good at graphs.
You don't have to. You just had to give the zeros and sit and make your.
Like on 3, no,
But you had to graph 3 and 6.
I don't usually just look at the graph.
On the other one, that said graph.
So on these you just have to find zeros?
And state the behavior. So how about this? It's going backwards. It says find a cubic function that has the given zeros. And when I give you a question like this on the test, I say write a polynomial function in standard form, which means I actually want you to multiply it out. But if they give me the zeros, think about that's like saying a 0 at 3, x equals -4, and x equals 6. And I just want you to go backwards and go from the 0 to the factor. Like, what was it before we solved it? X minus 3. What would give me a 0 of -4 would be the factor x plus 4. What would give me a 0 of 6? X minus 6. And again, that's not very bad. It does say write a function, which means you need to set it equal to y or set it equal to f of x. And on the test, I want you to work it out in polynomial form. And so let's just go ahead and FOIL this out. So if I FOIL these two out, I'm going to get x squared plus x minus 12 and minus 3x plus 4x. And then I got to FOIL it out with this. This is just some good old polynomial fun. So I get x cubed minus 6x squared plus x squared minus 6x minus 12x plus 72. Remember the good old days of Algebra 1 where you just FOILed this out all the time? So putting like terms together, we would get minus 5x squared minus 18x plus 72. Right now, everything we've done has been in factor form for us. The last section that we're going to do before we take a test is going to be finding the zeros if it's not in factor form. So finding the zeros from this, and that's where we'll have to talk about PRCs and synthetic division and remember all that fun stuff. There are some questions on your homework with graphing calculators, and we're going to do those tomorrow. I know I'm not going to be here, but I'm going to record a little bit, and I'm going to leave the graphing calculators for you to use to finish your homework. So make sure you pay attention to what the homework says here, okay? There's a lot of writing here. We're going to skip that one for now, because that's the graphing calculator one.
Whoa.
This is 2-3 day 2, okay? So you're going to do 9 and 12. You're going to do 39 and 42, and the directions on those say sketch by hand, but I just put them in parentheses to remind you. 39 and 42 are like the ones that we did in class today. We're going to do all that information, take a few points, and make a decent graph. 9 and 12 are matching, so that's not so bad. Then there's 3 here that the directions say use a graphing calculator to approximate the zeros. We did this already. We used graphing calculators to find zeros, but we're going to do it again because it's good practice. But we're going to do those in class tomorrow. I'll probably record doing 45, and then I will leave the graphing calculators, and your job will be to do 48 and 51. And then when you're done with 48 and 51, you'll give your graphing calculator back to the sub, and then the sub will give you your assignment. You don't need to write all that. I was just trying
Basically,
to...
9, 12, 39, 42, 54, 55.
Right. So in second hour, they said, can we just skip these 3? And I said, totally, you can just skip these 3 and put it on the end of your homework tomorrow. Or if you like your homework to go in numerical order, you can just number 45, 48, and 51 and leave spaces, and then jump to 54, 55, which I think are like our last example, where you have to write out the equation. Yeah. And then 71 to 73, I think, are multiple choice. I cannot stress enough how much you do your homework every night, kids. I don't check your homework every day because this is supposed to be similar to a college class. But if you're not staying up, caught up on your homework, you're going to struggle. And those of you that think that you'll just go back and do it later, most of the time that doesn't work. Talk to Mason. He had a big plan every chapter the night before the test. He would just do the whole chapter